Hello guys, welcome to this video where I talk about the preparation and the properties of oxygen. So here we're going to discuss how oxygen can be prepared and what are the various properties of oxygen. Now, oxygen can be prepared in the laboratory from either hydrogen peroxide solution or potassium chlorate salt. So let's start with the first one, laboratory preparation of oxygen from this hydrogen peroxide solution. Now the most common method for this preparation in the laboratory is this use of hydrogen peroxide solution. Now the gas is prepared by catalyzing the decomposition of this hydrogen peroxide with the magnesium 4 oxide. Manganese 4 oxide. Now at room temperature, hydrogen peroxide decomposes or breaks down very slowly. Now it decomposes to water and oxygen. Now to speed up the decomposition process and hence collect a substantial amount of oxygen gas within a short time, this black manganese 4 oxide is added as a catalyst. Already known that catalyst is the substance that speeds up the rate of chemical reaction but remain unchanged at the end of chemical reaction. So in the reaction like this, you get that this hydrogen peroxide decomposes to water and the oxygen gas by the help of this black manganese 4 oxide as a catalyst. Moving on, let's see the laboratory preparation of oxygen from potassium chlorate. Now oxygen can also be prepared by the thermal decomposition of potassium chlorate. When this compound is heated, it decomposes slowly into potassium chloride and oxygen. As you can see in the reaction, that potassium chlorate decomposes to potassium chloride and oxygen. Now the reaction can be speeded up by adding of a little manganese 4 oxide as a catalyst. Now let's see test for oxygen. Test for oxygen basically that oxygen rekindles a glowing splint of wood. No gases behave like this except this nitrogen gas, from which oxygen can be distinguished by the following properties: that oxygen has no smell, but dinitrogen oxide has a sweet silky smell. The second one is that when heated with the nitrogen monoxide, this oxygen produces brown flames of dinitrogen dioxide. Now the dinitrogen oxide has no effect on this dinitrogen monoxide. So the test of this is only that oxygen rekindles this glowing split of wood. Let's see the properties of this oxygen. The first one is that the reaction with specific metals, starting with the sodium. When burnt in excess oxygen, this sodium burns with an intense yellow flame to give sodium peroxide. As you can see in the reaction, that sodium reacts with oxygen to give out this sodium peroxide. The product is yellow solid which dissolves in water to give an alkaline solution. The second specific metal, this is calcium, whereby the metal burns in air with a red flame, giving a white solid of calcium oxide. So in the reaction calcium plus oxygen, you get calcium oxide. In the reaction of magnesium burns with a brilliant white flame, leaving a white ash of magnesium oxide. Let's see the action of oxygen on non-metals. Non-metals, we are going to see the first one is carbon, whereby red hot carbon combines vigorously with oxygen to form carbon dioxide, giving no residue. Sulfur burns with the blue flame, giving misty white fumes of sulfur dioxide. And when the oxygen reacts with the phosphorus, phosphorus bursts into flame in air oxygen without being heated. That's why it is stored underwater. a white solid phosphorus pentoxide is formed. Let's see the properties of oxygen. Here we are going to see about the physical and the chemical properties. Starting with the physical properties, it is clear, colorless gas with no smell. So oxygen, basically, it is clear, it has no smell, and it has no color. The second one, that it is a neutral gas, which means that it is neither basic or acidic in character. The third one is that it is slightly soluble in water. When take 100 cc of water at room temperature, dissolves about 4 cc of oxygen. The fourth one is that it has almost the same density as water, although slightly denser than air. The last one is that it boils at minus 183 degrees Celsius and it freezes at minus 218 degrees Celsius. Let's see the chemical properties. Basically, the first one, that oxygen supports combustion. So this is the one of basic property of is one of the basic chemical property of oxygen. It is a very strong oxidizing agent. And the last one, that oxygen is very reactive. It reacts vigorously with the great main metals and non-metals to form basic and acidic oxides respectively, as we've seen before. Let's see the uses of oxygen in our daily life. Oxygen can be used in the air, and that the oxygen in the air and that dissolved in water and soil is used is used by all these respiring organisms. So it is essential for the respiration of organisms. The second one, that is used in oxyacetylene or oxygen ethylene flame for welding and cutting steel. The third one, that it is extensively used for removing impurities from pig iron in order to produce steel. So oxygen is blown into this molten iron to remove impurities such as carbon or phosphorus, which are expelled in the form of gases. This means they are oxides. The fourth one, that oxygen is used also as an aid to breathing in hospitals, high altitudes, climbing or flying, and in deep sea diving. As you can see that there is production of there is collection and storing of oxygen in various tanks. These tanks are used in these hospitals, high altitude climbing, flying, and in deep sea diving. The other one is that liquid oxygen is used in burning of fuels such as kerosene, hydrogen, and hydrogen, used in various types of rockets. As we said that the oxygen supports combustion. The last one, it is used in the ready process for making steel. I hope it's clear, guys. So that's all for this video. Thank you for listening.